Need to consider friction on a plane briefly. The key with this is that if we've got anything on a plane, not only does it have its weight force acting down, it has a friction force acting up the slope and a normal force acting perpendicular to the slope. Note the weight force is straight down, which we need to consider in its components. If we do this with the triangle, we see the normal force and the frictional force forming a triangle with the weight force, and if we consider that in terms of the trig, we can do a nice little manipulation and we get sine theta equal to the frictional force over the weight force. Rearrange those and we get the frictional force equals force weight by sine theta, and a similar manipulation for the other one. Remember that frictional force is just mu times the normal force. We have our standard relationships for friction. Here's a problem to try. A pallet loaded with 250 kilograms of goods is placed on a horizontal wooden ramp. One end of the ramp is then lifted slowly until at exactly 30 degrees above the horizontal, the pallet begins to slide back down the ramp. What's the coefficient of friction between the pallet and the ramp? The solution just steps through how you rearrange mu to solve for force due to friction over force normal. Don't fall for trying to substitute mass and gravity into this. If we substitute those previously organized relationships for frictional force and normal force, we get a neat little relationship of mu, coefficient of friction, equals sine theta over cos theta. Sub in our values, mu is 0.58. The important thing about this, it's quite interesting and you'll get to explore this in the exam, is that friction is independent of mass. Enjoy.